we will complete, and then
Mm.
how that bridge is actually happening, the FSM of the bridge.
Mm.
I think that will be enough now. And then at last, codes and schematics.
Mm.
You're recording the session?
Yeah.
Okay. I'll ask them to come once.
Mm.
Then we start.
ರೆಕಾರ್ಡ್ ರೆಕಾರ್ಡಿಂಗ್ ಮಾಡೋದು ಸುಮುಖ.
Okay, Sumka, we'll start. I think Chetan didn't come yet.
Where is he?
So no, I called him.
He's not in room, huh?
No, no,
Oh,
he's
you're
not
still
in
in
room.
college.
I am in room. I am in Sachin's room.
Mm-hmm.
That guy is in library, I think. I asked him to join.
Mm-hmm.
Okay. You have those not APB's bridge
Mm.
thing and all, You
Yeah.
open the document or anything that is a
Wait, I'll share
reference.
from tab.
Okay.
ರೆಕಾರ್ಡು ನೀನು ಮಾತ್ರ ಮಾಡೋಕ್ಕಾಗುತ್ತಾ ಇಲ್ಲ ನಾವು ಮಾಡ್ಬೋದಾ ರೆಕಾರ್ಡು? ರೆಕಾರ್ಡ್ ನೀವು ಮಾಡ್ಕೊಬೋದು. ನಾ ಕಳಿಸ್ತೀನಿ ಬಿಡು. ಓಕೆ ಓಕೆ. ಲಿಂಕಲ್ಲಿ ಎಲ್ಲರೂ ಹಾಕ್ಬಿಟ್ಟು ಕಳಿಸ್ಬೇಕು. ಹ್ಞೂ. ಸೊ ದಟ್ ರೆಫರ್ ಮಾಡ್ಕೊಳ್ಳೋಕೆ ಈಸಿ. ಒನ್ ಸೆಕೆಂಡ್.
Joshi, so what we thought was first till 7 till 8:30 we'll continue with half of the like APB bridge side will come, APB side will complete. Then after having dinner and then we'll go to PG and then from there we'll start again the other half.
Okay, okay, no problem.
So
No
that we can
issues.
Till
complete
8
by
will do,
11.
huh? Until
Yeah,
8
a
will do.
little late is also fine. 9:30
Hmm.
afterwards. By the time we'll reach
Hmm.
PG, so actually seeing availability of you and the rest, we can push it.
Hmm.
Ajit, please off your mic, bro.
Okay. Okay, I'm not Chetan.
You are sharing the time.
1 second, I don't have bridge this thing.
Spec sheet of bridge.
Hmm. I have it on PC. I'll share it from WhatsApp.
Uh-huh.
Hmm. First, we'll start with bridge only or AHB APB separate.
Gives the overview of what my bridge is used. With that, I think two or three pics were there, no? Of connect how bridge is connecting the AHB and APB.
Hmm.
What are the peripherals of that?
Hmm.
That will overview of why we are using. Then we'll go with APB
Hmm.
and yeah. Chetan was Chetan completed APB, no?
Don't know.
Yes, sir.
Then you also add on to it.
Send me that image once more. Da.
Yeah, yeah, I'll send you.
This we can't see properly.
So
Right.
make it landscape.
We can't do wait. In tab it won't be cleared. I use Samsung.
ಅಲ್ಲ ಟ್ಯಾಬ್ ಅಲ್ಲಿ ಕ್ಲಿಯರ್ ಇದೆ ಆದ್ರೆ ಚಿಕ್ಕದಾಗಿದೆ.
ಹೌದಾ?
ಇದು ಲ್ಯಾಂಡ್ಸ್ಕೇಪ್ ಅಲ್ಲಿ ಇಡೋ ಸಾಕು.
ಸಾಕಾ?
ಹಾ ಈಗ ಓಕೆ. ಹಾ ಕರೆಕ್ಟ್ ಕರೆಕ್ಟ್ ಪರವಾಗಿಲ್ಲ. ಹಾ ಈಗ ಚೆನ್ನಾಗಿದೆ.
ಹ್ಮ್.
ವಾಟ್ ಇಸ್ ಅಂಬಾ ಪ್ರೋಟೋಕಾಲ್?
ಹ್ಮ್.
ಅಂಬಾ ಅಂದ್ರೆ ಏನು? ಅಡ್ವಾನ್ಸ್ ಮೈಕ್ರೋ
ಕಂಟ್ರೋಲರ್
ಬಸ್.
Advanced microcontroller bus architecture.
So basically, AMBA is something like when ARM is one who developed that. So for those architectures which they were using, in order to have communication between the peripherals of whatever, if we take microcontroller, you have everything on the same chip, right? So in order to have communication among them, there should be some protocol that make sure that whatever is transferring from one peripheral to other peripheral should not have any loss or should not be interrupted by any other peripheral. So for that there were some restrictions that they have kept, which are basically protocols. So protocols are nothing but certain restrictions that make sure whatever the transfer is happening is successful. So for that they have specifically designed how they need to be communicated from one to other, what are the restrictions. So there are phases also how it need to phase. So when you want to access something, basically everything comes down to either accessing the data or writing the data to certain address. So everything works in that fashion. So they have the phases of when to send the address, when to send the data. So in that specific AMBA protocols, there are certain protocols that works for high speed. So if you consider your on-chip microcontroller, everything that runs in a microcontroller have the speed of clock which is high. So the data rate of sending or receiving would be, let's say, in 1 second it is transferring some 1200 bits megabits per second. So those works in that frequency, and there are some peripherals that are outside the chip. So for that also, in order to communicate from on chip, let's say processor wants to communicate with a transfer protocol, which is UART works at lower frequency. So in order to transfer something, the data that need to be transferred from UART to other chip or something, so you need to have some certain what you say, a bridge type thing, in order to make sure this high frequency whatever is sending the data should be received by the low frequency that is there on the other side. So there are certain protocols that make sure this on-chip communication is happening, which are two of them are AHB and then AXI Advanced Exchange Interface or something. So we worked on AHB, which is a bit simpler than AXI, but both have the same high frequency protocols. So on the other side, which is for low frequency, they have designed something called APB, Advanced Peripheral Interface Bus Protocol, and then AHB is Advanced High Performance Bus. So these two, we need to make sure that there should be a interconnect that is sitting in between this low and high frequency thing, which is basically AHB bus and APB bus. So that should sit in between and store the data as we learned about async FIFO, that FIFO thing which we learned. So in that, we saw that if the data that is being sent from one side to other side, if the writing is faster than reading, you need to have a storage element that stores the rest of the bits which are there in order to make sure that they are not lost when it is reading at a slower rate. So it is very much similar to what a FIFO does. The bridge is very much similar to what FIFO does, but we have certain states that it transfer from one to other. So in the project also we didn't use any FIFOs and all. It didn't go in that extent. it is very much simpler than what it actually should be. So I think it won't take much time in understanding the codes and all. So that is a bit
What?
overview of why there is a need of AP bridge and what are protocols that are related for AMBA and which is working for what. Why are there so many protocols? So that's a brief about that. Any doubts on that, Joshua? Anything that you didn't got? Any even with others also?
Fine, fine.
Yeah, Joshua.
Okay, definitely.
Fine, no?
Yeah.
You can ask at any point of time in middle. It's fine. Basically, by the end of the session, we thought of completing APB, and then by end of today, we'll try to complete at least the theory part, and we can take 1 more hour from any other day. Even after the exams, also we can take one to understand how the coding is happening. So that would be enough for understanding it properly. Basically, even in the interview, they may be asking of rather than how you implemented, they'll be going through each what is the theory that is behind the both of them. So if that we understand from this class, I think it is enough to explain the interviewers about what we have done. So at last also we can divide of what we have done because they'll ask what is your responsibility, what was your responsibility or contribution to the project. So we can divide to what we have done. Let's just to say for them. So we'll divide and on that if you be perfect rather than knowing other thing we should know for a basic. But if we are assigned to something or if you say that I was responsible for designing the slave part of APB or anything in between. So that part you be more in depth of understanding it. I think that would be enough to just say them what we have done in the project. Sumuka, you start about I think you
One
start
second.
about APB.
Hmm.
You code, anything is done. Yeah, we can say.
1 second.
Any point in the meeting or like while happening, you can anybody can ask anything. It's not like teacher or something like that. So anybody can quote anything or any doubts, as if you are listening from the other side of an interviewer, and this guy is saying about what he have done in the project. So you be in that mode and ask any of the questions. I think that can make you also to understand things properly than just saying from the one side. Yeah. Yeah, Sumukha, you start with that.
Okay.
Huh?
Now I connected my tab.
Okay.
I'll share from laptop and it's working.
Okay, okay.
First, I'll start with what? Bridge or
Start with
SP?
APB. So basically, APB is something setting the other side, which is low frequency. But first, we'll discuss on that, and then we'll discuss on AHB, which is high frequency, which is working on chip. After this module, understanding of both of them, how they are working, what's happening in them, we'll try to understand with why we need bridge and what makes sure that the bridge is transferring from high frequency to low frequency. First, we'll by 8:30 we'll try to complete APB, and then in the other session we'll complete AHB and then bridge of that. Bridge doesn't take much of the time.
Hmm.
After understanding AHB and APP, bridge just only takes some of time to understand. So because we didn't do it in depth, so there is only certain things that we need to understand to just understand what is bridge taking off. So that's it. You try to give APB, explain about state missions that are in APB, how
Hmm.
they are transferring, and that's enough. I think it is simple. Only three states are there. So
Hmm.
give an overview of that and then explain the state mission and the
Hmm.
signals that are there. I think that, that would serve.
Wait.
Sumuka, just check whether it is recording.
Record after.
Okay.
Hmm. So these are the transitions in the timing diagrams.
Make it full screen. You do F11 once. Okay. You give it in Kannada only so that they'll understand. Faster.
ಓಕೆ.
You can also communicate it properly.
ನೋಡುವ. ಇದು ಟ್ರಾನ್ಸಿಷನ್ಸ್ ಏನೇನು ಇಂಡಿಕೇಟ್ ಮಾಡುತ್ತೆ ಅಂತ
டிஸ்கஸ் பண்ணலாமா?
என்ன அப்ரூவ் பண்ணலாம் சார்.
சரி. அம்மாக்கும் அதே ಅದೇ
ಹಲೋ ಹಲೋ ಹಾಂ. ಸೊ ಇದನ್ನ ನೋಡ್ಕೊಳ್ಳಿ. ನಿಮ್ಮ ಹೈಯಿಂದ ಲೋಗೆ ಹೋಗ್ತಿದೆ ಅಂದರೆ ಹಿಂಗೆ ತೋರಿಸುತ್ತೆ, ಹಿಂಗೆ ಇರುತ್ತೆ. ಮತ್ತು ಅದೇ ಥರ ಹಿಂಗೆ ಟ್ರಾನ್ಸಿಯೆಂಟ್ ಅಂದರೆ ಸಡನ್ ಸ್ವಿಚ್ ಆಗ್ತಿದೆ, ಲೈಕ್ ಸಡನ್ ಚೇಂಜ್ ಆಗ್ತಿದೆ 0 to 1 ಆರ್ 1 to 0, ಇನ್ಸ್ಟಂಟೇನಿಯಸ್ ಆಗಿ ಚೇಂಜ್ ಆಗಿ ವಾಪಸ್ ಬರುತ್ತೆ. ಸೊ ಅದು ಟ್ರಾನ್ಸಿಯೆಂಟು. ಮತ್ತು ಹೈ ಟು ಲೋವರ್ ಹೈ ಆರ್ ಲೋ ಟು ಹೈ ಅಂದರೆ ಯಾವುದೇ ಆಗಿರಲಿ ನೆಕ್ಸ್ಟ್ ಹೈ ಹೋಗ್ತಿದೆ, ಡೋಂಟ್ ಕೇರ್ ಇದ್ದಂಗೆ ಆ ಥರ. ಇದು ಸ್ಟೇಬಲ್ ಬಸ್ ಅಂತ, ಏನು ಸಿಗ್ನಲ್ ಇಲ್ಲ, ಸ್ಟೇಬಲ್ ಇದೆ ಬಸ್ಸು. ಅಂದರೆ ನಿಮಗೆ 1 ಇದೆ ಇಲ್ಲ 0 ಇದೆ, ಟ್ರಾನ್ಸಿಷನ್ ಆಗ್ತಿಲ್ಲ. ಮತ್ತು ಇಲ್ಲಿ ಬಸ್ ಟು ಹೈ ಇಂಪಿಡೆನ್ಸ್ ಏನೋ ಇತ್ತು, ಆಮೇಲೆ ಹೈ ಇಂಪಿಡೆನ್ಸ್ ಆಗ್ತಿದೆ. ಬಸ್ಸು ಚೇಂಜ್ ಆಗ್ತಿದೆ ಅಂದರೆ ಅದು ಇದು ಸಿಂಬಲ್ಲು. ಆಮೇಲೆ ಇದು ಹೈ ಇಂಪಿಡೆನ್ಸ್ ಟು ಸ್ಟೇಬಲ್ ಬಸ್ಸು.
Basically, the transition that happens in the waveforms. So this is a spec sheet of APB, which covers all the waveforms. So basically, in order to understand how the data is getting transferred or what is happening on the bus, everything will be said with respect to waveforms. So we need to understand what a part is representing, with like how is the transition happening, or which is stable or which is transient. So in order to understand, those things should be known of how it is happening, what representing is what. So if we understand the waveforms a bit, it is proper, like we'll understand how the things are getting transferred. So that is brief about that. Yeah, I use it.
This and all is required.
This spec sheet, this bridge one.
Yeah. Or I'll go to APB first.
Yeah, go to APB. Yeah.
So
you that state diagram or master is that you open one more space of similar that to half of the space will be seen with the master, and then you explain the signals. It will be easier to understand.
right.
Like how you on that day you just showed the one on the other. Like that, if you show it will be.
Where is the diagram?
It will be down or something. In APP, I don't think slave is there. See once.
It's not there, I think. APB simple only.
Okay. You go with the signals only, saying how the signals.
ಸೊ ಸಿಗ್ನಲ್ಸ್ ಇಷ್ಟಿದೆ APB ಅಲ್ಲಿ. ಒಂದು ಕ್ಲಾಕ್ ಇರುತ್ತೆ, ಒಂದು ರೀಸೆಟ್ ಇರುತ್ತೆ, ಅದು ನೆಗೆಟ್ ಆ್ಯಕ್ಟಿವ್ ಲೋ ರೀಸೆಟ್ಟು, ಅಡ್ರೆಸ್ ಸಿಗ್ನಲ್ ಒಂದಿರುತ್ತೆ, ಮತ್ತು ಪ್ರೊಟೆಕ್ಷನ್ ಸಿಗ್ನಲ್ ಟು ಇಂಡಿಕೇಟ್ ವಿಚ್ ಪ್ರೊಟೆಕ್ಷನ್ ಟೈಪ್.
Have not implemented, you neglect only with respect to which we implemented, you just say on that.
P selects to select whichever slave is required, peripheral is required. ಮತ್ತು P enable to enable following cycles of the transfer. P right.
ಸುಮ್ಮನೆ ಕಳಿಸ್ರೋ ಮ್ಯಾಚ್ ಪಾಯಿಂಟ್ ಹಿಂಗೆ ಆಗ್ಬಿಟ್ರೆ
பெரிய பார்க்ல ஃபர்ஸ்ட் ஒரு நிமிஷம் நான் ப்ராஜெக்ட் டிஸ்கஸ் பண்ணிக்கலாம்.
நம்பர் அம்மாவா சொல்றேன். இந்த கூட இந்த
கேட்கல. Hello. So you have P write signal to indicate whether you are writing or reading. P write data. P strobe signal to use a particular lane, like byte lane, while transferring. This and all not required.
ಅದ ಸ್ಟ್ರೋಬ್ ಏನು ಹೇಳು ಪಿ ಸ್ಟ್ರೋಬ್
ಸ್ಟ್ರೋಬ್ ಈಗ ನಿಮಗೆ ಡೇಟಾ ಬಸ್ಸಲ್ಲಿರೋ ಎಲ್ಲ ಬೈಟ್ಸು ಯೂಸ್ ಮಾಡ್ತಿಲ್ಲ ನೀನು, ಸ್ಪೆಸಿಫಿಕ್ ಯಾವುದೋ ಲೇನ್ಸ್ ಯೂಸ್ ಮಾಡ್ತಿದ್ಯಾ. ಸೊ ಅವಾಗ ಅದು ಹೇಳ್ತೀನಿ ಇನ್ನು ಇದೆ ರೈಟ್ ಸ್ಟ್ರೋಬು.
So basically, if you have a data bus of 32 bits that can width of 32 bits, and you have this functionality with the APB or any AMBA protocol, if you take, there is this thing which is making which can make bus width reconfigurable, and the size of data that we are transferring like we can send an 8 bits or 8 bytes anything. So we can reconfigure ourselves to send how much data that you want. Let's say you are working on any UART thing that is transferring, and it has been kept for 8 bits. So at a single transfer, it will transfer 8 bits. So now we have a data bus of with 32 bits. So at a stretch, you can send 32 bits, but you don't want to, because your UART is capable of supporting 8 bits at a time. So at that point of time, you change the signals. So every line of the bus with have a line. So with respect to that, there will be a number. So we make sure if you are accessing 8 or first state or last state, you make other lines as off, so they won't have any functionality that is happening in that buses. So that lines. So for that, in order to select a particular number of bits, which gives the functionality of reconfiguring your bus width. So and if you have 32 bits as maximum physical data bus width, and you want to send 64, that won't happen. So physically, how much you have, that would be the maximum width that would be maximum bits that you can transfer in one single transfer. So maximum that you can do, and minimum is 8 bits. That is 1 byte. So for that, but we didn't have any signal in our project that is working with strobe. It is good to know that what strobe does, because we don't know how each protocol works in the APB. So APB have majorly protocols system. So you have SPI that is sitting on APB as a peripheral. So it is good to know what strobe makes sure that it selects a particular set of data lines in a bus. Yeah, that's about it. So you don't have to consider it in the for the project, but just to know it is okay. Yeah.
So what else to say in this?
when and where these commands are used,
Comments of
these P strobe and all.
these are
Signals.
actually signals. Okay, so let's say 1 second. I'll take one picture out of. Show that photo once.
1 second, I'm searching for it. You didn't send that. You sent this.
This one only you show. So this is not actually what Joshua asked. This is just to know what is sitting on. Like, I have explained what is the need of bridge in between. So see, your other side, which is high performance ARM processor, everything is sitting on chip, and to have the transfers from one bus, let's say from processor to DMA bus. DMA is something like direct memory access. So every component that is there, like printer or keyboard, anything that have DMA. DMA is something where it works with the speed of processor, but on the other side of DMA, you have printer which is working at slower frequency. So DMA takes the data from processor or the request or anything from the processor, and it will keep with it, and according to that it will share with the printer. So it is basically doing the work which is bridge doing in this context. So everything that is with high frequency are sitting on AHB, and you at your timer, your keypad or PIO, which are at lower frequency, will sit on APB. So bridge is something that is transferring from one way to other. This is brief over that, and I'll share one second. I'll share one. So I'll try to call you.
ಸುಮುಖ ಆ ಪಿಕ್ಚರ್ ಕಳಿಸ್ಬಿಡು ವಾಟ್ಸಪ್.
You make zip of everything and send. Yeah, 1 second. Yeah, say da. So basically, this will be in the signal level, which we just saw.
Reddy.
Yeah.
AHB and APB work at different frequencies.
Yes. So let's say because say your processor is working on gigahertz, and your processor was working at gigahertz, but your peripherals which are there at which are at APB will be working on megahertz. Like that is 10 to the power of 3 times faster than what you say peripherals. So that's the thing. That is obvious, no? So when we are seeing something that, like, see your processor, it executes so many transactions, so much of processing happens, but when you are seeing things, it would be slow, or you are receiving data using Wi-Fi or something that is slower than what it processes on. I think is that answered your question, Rashi?
Bro, does it have two crystals for clock in the hardware?
Two
Crystals for clock.
Yeah, the main crystal is basically it will not generate gigahertz and all. That's where PLL comes, phase lock loop. So crystal is where you make crystal oscillator, make sure that your whatever the frequency oscillations that you are generating are stable in nature, but they generate with some megahertz of frequency. But PLL is something which is not stable with respect to the oscillations that it is happening, and but it can make the frequencies in gigahertz, which we use on chip. So crystal oscillator will be as a reference to show how stable a signal should be, and PLL sees the reference signal of what is in crystal oscillator and generates it in gigahertz. So whenever there is a mismatch that is happening or instability that is occurring at gigahertz frequency, which is generating by PLL, it will make sure that it again comes and sit to a stable state. So crystal,
Okay,
you'll have only one crystal as a reference
yes.
for all the chips, and from that crystal every module will have a PLL block which generates the respective frequency that is required.
So that crystal is at one crystal, how it is divided, clock is divided from that one crystal.
Yeah, as I said, crystal generates in megahertz. PLL makes sure that it multiplies the whatever the crystal frequency is there. Say if crystal is generating 1 megahertz and you want 3 gigahertz, so PLL will be made accordingly to see that it is generating 3 gigahertz of frequency. So, and if you want to divide it, everything, so there is something called DLL, data lock loop. So that DLL will try to divide as how we use frequency, like the counters and all. in order to divide the frequency. In the similar fashion, you have DLLs and all in the analog to divide those frequencies according to the working of that particular block. Either it may be processor, it may be any other component. Yeah, that's it. Anything else? Uh,
No, da.
so as you asked about the signals and all, it is good for everyone. So internally, as we saw there in a block diagram, this is how internally they are connected. So you have something H clock which is running at high frequency, and then these are the signals that are taken by slave, which are getting from the master of AHB, and slave takes it. Which this whole thing is a bridge actually, internal of a bridge. There is something called a FSM that is designed particularly for bridge, and that makes sure that these are transferring from one, like let's say your AHB master have asked for an address and the data in that address it want to read, so you'll send that address from the bridge, from the bridge to APB, but this address will be sent by the AHB master which is there on the other side, and that will send to AHB slave which is a part of bridge itself, and then that decodes it into H address, and that address goes to FSM, and then it transfers it again to something which is at APB. So this is APB interface which interfaces with the APB slave on the other side. Let's say UART you have, and it works on that. So let's say you have UART on the other side, and it takes the address data, and with respect to that, it will send things. So this is how internally they are connected. So each signal describes what it is actually used for, what is the significance of that. So basically, in the project we don't have peak clock. If you can see, there is no peak clock, and APB interface is what working as APB slave. It may be confusing now, but you should not say it in the like basically all the projects that are on bridge, on web, or which is given in the spec sheet doesn't have a peak clock that is generated. So there is other way, something called as toggle synchronization, which we didn't use and which is a bit complex and all. So we don't see a peak clock here, but you should not mention while you are explaining to the others.
What is what, what
Yeah,
is peacock? Da? Peacock.
P clock is the clock on which the peripherals are working. H clock is the clock on which the whatever the peripherals connected on the AHB are working. So it
Okay.
is the clock. So we didn't give any P clock, which P in a sense peripheral, H in a sense high bus. Okay.
Then a P clock means separate clock for this APB, no?
Yeah, separate clock. So both will be separate. When you have some, basically when you have a different clocks, you need to have an FIFO in between, sitting in
FIFO.
between, or any memory element that is sitting, making sure that whatever the data is not yet read or written should not be lost. So that we have not done because it increases the complexity of adding FIFO in between of each and everything. So we don't have that, and it is no, it is okay that we don't have it. It's not mandatory that we should have and show it.
What is like the relation between peacock and H clock? Oh, actually,
There,
what is the basic difference?
basic difference is your P clock is high, your P clock is low, and your H clock is high. See, if let's say a master which is working at high frequency, so it wants to send a 10 bytes of data. So 10 bytes of data with that frequency, it may send it in 1.5 millisecond or less than that. And APB is reading that, which is working at some say, a megahertz. So if that takes time of 1 second to read. So for writing, it is taking 1.5 milliseconds. For reading, it is taking 1 second. That is 10. It need to hold that data which is there until 1 second of it reading. So that difference will be there. So how fast you are writing or how fast you are reading is dependent on the clock that it is working on. Okay, but while coming here, your APB is at slower rate of receiving or transmitting. and your AHB is at faster rate at receiving or transmitting. So you need to make sure some interface should be there that holds this data of writing or reading. So that is basically difference. There won't be any relation among them, but as we see, like, there will be difference of speed. So that difference we should see, and we should make sure how much the depth of FIFO should be. But we have not implemented the FIFO depth. We don't have a peak lock. So we are considering it as a in the project. We are considering it as a combinational circuit. So nothing you have when you get get a signal which is right, it will write a random data just to make like we are mimicking how the slave works. That comes to we'll come to know when it is in the project, when we'll see the project module how it is very low code. So it works. It's like combinational circuit. Once you get something, your memory will write the data into that bus. So we don't, because to reduce the complexity and also to properly explain or understand the interface, we have removed that. So that is removed. Like it's fine for removing it and understanding. There won't be any change, rather except you having a FIFO in between. That's it. Understanding wise, everything will be same. FSM wise, everything will be same. How they are transferring from one to other. So the only thing that remains is the FIFO depth or depth. So until they ask you how you implemented about FIFO or something, then you should mention. So until that, you just explain what is the bridge working on. Okay. Any doubts other than that? Anyone? Or even Joshua, have you understood that?
Yeah, okay.
Okay.
Right.
What happened, Chetan?
No doubts, sir.
No, no doubts. Okay, okay, fine. Fine. So yeah. So this is our internal connections of the signals. I'll stop sharing and soon I'll go from there.
We'll go to signals like what's that? Transfer signal state
You
what
show the
is
signals
timing
and say
diagrams.
what is what.
Hmm. That I told no.
Okay, okay, fine. You explain it with the timing
Timing
diagram. It
diagram.
will be clear.
Hmm. So we have two types of rate transfers without any wait states, with wait states. Hmm. So we are sampling at the rising edge of peak clock. So if you see here, at this pass edge, the address will be sampled and we are asserting the write signal. And this p select of the respective slave will be enabled. So p enable will go low during the address phase, and we are giving the data at the same passage because we are writing. Then p ready should be asserted again after one passage, like next passage. You only explained that better.
ನಮ್ದ್ರಲ್ಲಿ ಪೀಕ್ ಲಾಕ್ ಯೂಸ್ ಮಾಡ್ತಿಲ್ಲ ಅಲ್ಲ ನಾವು.
ಹಾ ನಾವು ಯೂಸ್ ಮಾಡ್ತಿಲ್ಲ.
For now, you consider P clock and H clock as same.
ಓಕೆ ಓಕೆ.
There is no difference between them. And
Hmm.
if they both are same, there is no need of bridge. But just consider in that way. And when we come to the explanation of Verilog code of that, you'll come to know that there is no clock, but it is acting as a combination circuit. For now, just understand what is APB and what is AHB, and then we'll try to get with the bridge so that you'll completely understand.
ಓಕೆ.
So, yeah, so I'll try to explain this. So, in here, we see a P clock, which is the clock that is based on the clock, everything works. So, P address makes will say what address it needs. Like in this particular, so we can see that I'll share it with Edge
Hmm.
on
Yeah,
Windows
okay.
only. You
Okay.
send that file once.
Hmm. I'll send on WhatsApp.
Yeah, fine.
I'll send everything, image, everything.
Okay.
Shared.
Yeah. So so after understanding what is the significance of each signal, we'll see how transfers are work. So basically, a transfer says something, a data is getting transferred from one place to other. It may be with respect to write. Let's say here, for this there is a master and there is a slave, and you are transferring from, let's say this is master, this is slave. A transfer is something that is making a data transfer from one to other. It may be either from slave to master or masters to slave, like that. So, but every transfer will have certain signal that need to be asserted or deasserted to make sure what is happening. So when you're transferring something from master to slave, so this master slave, one thing we should understand is when we are speaking about master or slave, when masters this configuration comes into picture, you should understand that master is the only thing that initiate a transfer for anything. Either it may be read from the slave, the slave is giving the data to the master or master is giving the data to the slave. It's just the master who is starting the transfer. It can't Slave cannot transfer anything, cannot initiate a transfer. Initiate in a sense giving, sending data or receiving data can't be done by slave. So that's why we call one as master and one as slave. But in the spec sheet, when we go through spec sheet, we'll call this as manager and this as subordinate. So maybe the way of naming them would be different, but the working is similar. So here we see no wait states or wait states. So these are something, let's say you have address that is taken from master to slave, and a slave wants some time in order to write. Let's say this master is asking the slave to read something from the slave address. Let's say you have a block of address. Let's say this is some 28 or any address line, and there is some data in it that is there, which is of 8 bits or anything, any size. And your master is asking the slave, which is APB slave, and let's say this is APB master, okay? And in future, we'll see that APB master is nothing but the bridge. So this part is taken by the bridge. Okay. So now, slave is asking the master to send. Master is asking the slave, which is called retransfer. So the master is reading everything what we see as read or write is with respect to the master. So master is reading something from the slave. So first he'll transfer address to say that slave, please take this address and send the data which is there in that particular address. Okay. So now this, when you transfer the address, slave will let's say slave is working at a slower speed. and wants to have some time to process the address and then decode the address, then take the data and then put on to data bus. So this whole thing which is happening in the slave may take some of time, which is more than this clock. Okay, this clock period. So then slave will have a functionality that can make sure that slave is adding some more time to that. That happens with p ready. So whenever there is p ready which is low, it will say p is from, let's say whenever p ready is 0, which is been given from the slave will have this signal. So when it makes it 0, then it indicates that your slave is wanting some more time in order to complete the transfer. So whatever we have done in the project is with 0 wait states. So when that is 0, then only the wait states are added. Wait states are nothing but I'll show it in the next slide. I think it will come next. So based on this p ready, it will indicate whether the slave wants time or slave doesn't want any time to put the data. So p address indicates what is the address that is. So whenever we see like this, it is bus. This and these are buses of so let's say any bits, 8 bits or something. So this shows the address, and now this will be kept by the master. Master will send an address, and then then slave will react to that data. This is write transfer, no? So in write transfer, your master want to write something to a slave for a particular address. Master want to write. So first it will assert the address into the data bus, and the slave will see the address, and a particular slave will be selected. Let's say we have, so as we seen in the block diagram, we had many slaves that are on there on the bus. So you want to connect to one of them. Everything will have a select line. There is a port which is select, and when a particular slave's port will get high, that slave will start working. And then p enable says that the slave whatever is there is uh, being enabled as it's working. It's similar to how we have enable for decoder or encoder or any combination circuit. It is similar to that. After that going to one, your slave starts working. So at this particular time, your slave will see the address and the data, and it asserts a ready as one, which is that the slave have taken the address and read the data what is there and have written the data into the particular address which is at the slave side. Okay, and that's everything about that waveform. Any doubts that with respect to this? Anyone?
So are we implementing with wait states or no
No,
wait states?
in the code we don't use any wait states. It's within one whatever we are doing, it happening in one without any wait states. One transfer will happen that completes everything.
Okay.
So when P ready is there,
Yeah.
it will read the data also, and it'll take from P ALEL
Yeah.
also.
In this whole
Okay.
time, slave will try to take the address and that particular data. So first it will decode the address, and it says that okay, this address is present. Okay, and then
What
if
about
it is
right?
this is right.
Yeah. Which one?
So now the master, whatever you see here as a write is from the master side.
Okay.
Okay, so now your master is writing data to slave. So this whole thing makes sure that the master is writing a data into the slave. So the slave assigns this signal which is there here, p ready. So p ready high will say that slave is ready and it is taking the address, and in that particular address you are writing this particular data. So end of this transaction, there will be a data cell which have particular address and that have particular data which is given by the master. Okay.
Okay. Okay.
Okay. Any other questions?
Only when the P ready is high,
Yeah.
so the master will send the
No.
Yeah,
Master, irrespective of the P ready, master will keep the data on the bus and the
okay,
address on the bus.
okay,
P ready is indicating that slave is ready. So P ready is indicate this is the control that is being taken from the slave. Slave will have what need to be kept as P ready. The P ready indicates that slave is ready and it takes the data. And
okay,
we'll see this functionality of P ready comes into significance when we want wait states. Okay, so
okay,
that
okay.
will come in the next slide. Any other than that?
Yes, yes.
Oh, okay then. Okay, so that's about that. He explained this. There will be phases that slave will undergo. APB will undergo. I'll show that state diagram and explain after completion of this. That will be easier to understand. So yeah, now here wait states. Wait states we have not implemented as said before. So you don't have to know how it is implementing in the actual code, but it's good to know that how the wait states are getting added because of what it is getting added, how slave is making sure that it is adding wait states. Okay, so now we should, whenever it is wait state, we should just see the p ready. Okay, now everything is common, everything is similar to what is happening in the before waveform. The only thing that is there is p ready. So p ready in the before case was this part. Okay, but in this now it will take the address. When p enable is 1, it will try to take the address only when p enable. I've said when p only when the enable is high, that circuit will start working. It is it is similar to what we have in the combinational circuit as an input. So in the enable, when the enable goes high, it will take the address, it will try to decode the address, and it will see that this is taking a bit more time in order to get back the data or write the data into that particular address. So then the slave tries to make p ready as 0. When p ready is 0, that will say that it should have this address or this data stable for the next cycle, because it indicates that the transfer is not yet completed, and it needs some more time in order to decode, process, and write. So that time, when master sees the signal from from the slave that it have asserted the period as 0. So this is something that is going as an output from the slave as an input to the master. This master will see that it is 0, and he tries to hold this address and data for some more time until this gets ready. Okay, so when it goes high, then it will say that okay, I have decoded the address, I have written the data into the particular address which I have specified, and it goes high. After this, okay, master will understand after seeing p ready as 1 to deassert whatever he have kept in the address 1 or data 1, and make sure if there are some more transaction that need to happen, this bus will be replaced with address 2 on the other side, data 2 on the other side. So this is the major use of wait states. P ready is what signifies when to add a wait state. P ready is basically saying, the name suggests, that if either slave is ready, taking or writing the address, or it is not ready. Okay. Based on that, master tries to hold things what are there in that. That's it. Any doubts in this particular thing? Okay, so that's all about APB, and now we just want to see how it's actually getting transferring, how the transfers are. Okay, we'll
Danny,
retransfer also in the same way.
hello Danny.
So yeah, yada,
We have used keystrobe in our project.
yada.
We have used P-stroke in our project.
Some doubt is some sound is coming from your side.
Wait, I will type.
Hmm.
He's asking whether we have used.
We have used P. No, we have not used P stroke and all. So P stroke we have not used in the transfer. So it is very much simple that it just have something called write, something called read, something called enable and ready. Ready also because we don't use any of the wait states. This is just always been in high. Okay. So the significance of ready is also not there. Just to mimic the nature, we just kept p ready. So it is very much simple. You have a clock, you have an address bus, you have a write signal. So write basically says which of the direction you are right. So in the previous write was high. Okay. So in here, yeah, here right is high. So it indicates what is the direction in which it is transferring data. So when write is low, that means your direction of writing is from slave to master. Okay. When it is high, the direction is from master to slave. So it just indicates the direction of the transfer, data getting transferred. Okay. Is there anything other than that? So read transfer is very much similar to what we have seen in the write. So, but it's the only thing that you need to change the perspective of what is writing to where. Okay. Now your slave is trying to give some data to the master, but the transaction transfer or the transaction that is initiated is from the master. Master will only say which it want to write. So all this write signal, select signal, enable signal, and till here everything will have a control from the master. Okay. And this r data and ready will have the control by slave. Okay. When it is reading, like when the master is reading. Okay. So when it is writing your pw data, this will be pw data. So you have two buses, one bus particularly for writing, one bus particularly for reading. Okay. Just to not have any confusion on which data is written on which bus. So you have PR data and PW data. Now, so these are the two things that are controlled by the slave in read time. And if you have write, this is the only thing that is being controlled, okay, by the slave. Now coming to that, your P address is being given by the master, and master is asking, okay, you give certain data which is there in your system at a particular address on the bus. Now P right will say that okay, you have enabled it as 0. Master makes it 0 in order to indicate that slave need to give the data and the direction. Okay, and after seeing this too, slave will come to understand that okay, master is asking some data need to be given from the particular address, and then particular select line will be selected by the master for which it want to get the data. P enable is enabled. At this point, your slave starts working. Now, your slave takes the data, takes the address, sees the data in that particular address, and it will push that data when it is ready. Okay, when it is ready, I think when it is ready, yeah. When it is ready, it will push the data into the bus. So it is basically saying your transfer is have happened when it is ready. At this particular point you have data that is valid. So all this thing whatever is there here is don't care, we don't care what data it is because it is an invalid data. Okay, though the master have access to the data what is there here, it is invalid because it don't want the data which is there in that, which is some garbage value which happened in the previous transfer. So when p ready is high, that indicates that master, okay, now I have made the p ready. Now you take the valid data which is there after asserting the p ready, and master sees the data which is valid at this point, and it takes the data and it tries to do some manipulation or anything that is happening with this particular data. This is about retransfer. Okay, and wait states are similar to that, which we had with p ready. Yeah, only when p ready is high, your master will come to know that the data which is written by the slave is stable and valid, and it will take back that data. Okay, anything you want to ask from read transfer or anything that is happened till now? Yeah, anyone? Okay then. So yeah, that is a brief about APB. So,
Yeah, in APB,
yeah,
that's it, no? This is all the process in APB.
in APB,
Only these are the processes, no?
yeah, in APB you write or read. Even in AHB you write or read. That's the only. But how you are writing, how you are reading is different.
In APB also, we need to know how we read and how we read. Like in AHB, I saw sequencing, burst, and how to read the data.
Here with Joshua, Chetan.
Yeah,
Yeah.
yeah, he is with me. Yeah, Nikhil and all are there.
We are in SSH, we can't speak in this thing, the library, that's why you can get SSH.
You can speak in the library also. Okay, it's fine. So what you are asking is you are asking about state diagram.
State diaphragm, I got it, Radhani.
Ah,
Like the transfers are there, no? In this
yeah, you
APB,
have only wait and like you have only read and
read
write.
with and
But
without
with
waiting, no?
AHB, you have something called burst transfers. That will come to
That's what I
see.
asked.
Come.
We don't have a bus transfers in APB, na?
No, no,
Only
no.
these four.
Yeah, only these two.
Fine.
Read and write. Okay.
Hmm.
So coming to the state diagram. State diagram
So
is
whatever, so
yeah,
I have a doubt. So
yeah, yeah,
whatever we have, like we have came across till now,
yeah,
that is
yeah.
basically the transfers.
Yeah.
So is it like only the communication between the master and slave of APB, right? Not
Yeah,
AHB.
from APB on. When we come to AHB, we'll see something called as burst transfers.
Okay,
So
okay.
you send the burst of data of incrementing the address, you'll send some data. So it
Okay.
happens one after the other. That is the only difference that happens in AHB. And one more thing is your AHB works with a pipelining structure of two phases. How we have pipelining in architecture as first you have a fetch phase and then you have a decode. So until when an instruction go to decode phase, the other instruction start fetching, right?
Yes,
So
yes, yes.
you have that pipelining structure which is very much similarly happening in the AHB, that is data address phase and data phase. One
Mhm.
so when you have one transaction that have given the address onto the bus and going to the data phase, your second transfer will give the address to the bus. So that happens in that manner, in the pipeline manner. That's the only thing that we concern of doing as a bridge. So bridge makes sure that until that pipelining should somehow get converted into normal thing, which is APB. APB don't have any pipelining structure. That is the major difference that you need to mention even when they ask what is the major difference that we see. So one is the frequency of operation, one is the pipelining structure of AHB, which is not there in APB. So we somehow need to compensate that cycles what are happening. So that will come to see when we are working on AHP, and then bridge, how bridge is making sure that this is getting fetched properly, or how that pipelining structure is converting into a normal phase into a single phase. Okay.
Okay, so in single, in APB, it is going to be single transfer, right?
Yeah. So you have first address until the address and date of a transaction completes. You can't
Okay,
start an address of other and data of
okay.
other.
Mhm.
So you need to make sure that your address and data is available until you go to the next transfer. But in the AHB, it is like let's say you have put the address and you went to data, and you don't have to make sure that your address of that transfer is there or not. And by the time next transfer will come and put the address of that on the bus. So it is like when you have data phase of transaction 1 T1, you
Okay.
have address phase of T2.
Hmm.
Okay, so that happens. But in APB, you should have address of T1, address of data of T1 at the same time. Okay,
Okay. Okay.
that we'll come to know when we see it in historical form of how that pipelining is working. I'll try to show you that. Yeah, that's
Sure.
about that. Any check, anything I need to. Anyone? Okay, okay. I'm going to the next. I'll try to show the FSM. So FSM basically, as I said, how the APB tries to work. What are the phases it undergo? Everything goes with phases. Yeah. So these are the operating states we can also call. So how is it operating? So everything that happens in APB happens in 2 cycles. Okay, this is very much important. Everything that happens, every transfer that happens in APB takes 2 cycles of time to complete, wherein your AHB takes only 1 cycle to complete a transfer. Okay, so you need to add one more cycle in order to get this AHB compatible with APB. This 1 cycle is what the bridge will try to do, adding a flip flop. That's the whole core thing that you need to understand. In order to
Can you repeat
compensate,
once again? Can you repeat it?
okay. So everything that happens in APB will takes every transfer. When I'm saying everything means every transfer. Each transfer in APB, to complete a transfer in APB, you need to have 2 cycles. 2 cycles in essence, don't consider whether it's APB like H clock or P clock. By now, you consider it as a H clock in our case, but in reality, it is P clock. 2 cycles of P clock is taken in order to complete a transfer. Wherein in AHP, it takes only 1 cycle of H clock to complete a transfer. Okay. Now because we considered both our H clock, that means it is taking 1 H clock to complete a transfer. It is taking 2 H clocks to complete a transfer. And you need to hold the data for 1 clock, 1 H clock to compensate with the APB from AHP. And this 1 clock will do what this 1 clock is given by the APB bridge, AHB to APB, which is just by adding a small flip flop that tries to get the delay of it gets 1 cycle of delay. Okay, so this is the whole what you say the core of what APB actually does, the bridge actually does. And what is the difference that is there in APB and AHB? Okay.
So, do you
Yeah.
mean like a transfer means sending the data or even reading the data, like write data or read data together, or is it
Anything,
separate?
right? That anything which is single, anything that's let's say you are taking a single transfer. We only it's not double. It's
Like
only single.
write for
Yeah.
like 2 cycles,
If you
then
take yeah, if you take a write, it takes time. It takes 2 cycles to write the data on the bus. Okay.
okay.
If it is read, it takes 2 cycles to read. Okay, that's what it is representing here. I'll briefly say what the state diagram, how it is making sure that it is taking 2 cycles.
Yes, yes.
The state diagram is nothing but replicating your behavior of APB. Okay, so
Okay.
every component that is there in peripheral will work with this particular instruction with this particular FSM. So everything will have a particular FSM, a module, a small module that have this particular FSM, and whenever it wants to transfer data, it goes through this states, and with respect to this states, corresponding to those signals will be activated or deactivated, asserted or deasserted. Okay. So now, as I said, 2 cycles it takes. So first is, yeah, basically it is idle. So there is no transfer that is happening. It is just sitting as an idle case, and your master try to have some transfer. So this, how can I paste it? And so I'll try to show the waveform and that also. So this is, so now we'll try to see the right transfer. How is it happening? Okay. So in the ideal case, you don't have any. This whole thing says how that bus is working. APB bus. Okay. AP bus. Okay. Now, this thing. With respect to waveform, we'll try to understand each one. So this is the state that it is happening in this particular time. Okay. And when the transfer starts, when there are valid bits that are there on the bus or in the signals of P8 or something, slave will, the bus tries to indicate the particular slave to get activated. So when there is a transfer that is happening, when this transition is happening, this state gets transferred to this place. Okay. And now in this place, you have, when the transfer is happening, then there are valid bits that are there. I'll try to send it a color. So in this place, you are selecting a particular slave, any slave that is getting selected, but your slave is not activated. Your slave is active, but it is not activated, which is this part. Okay, so which is this part. A slave is getting selected, but it is not enabled. You have, see, you have a valid, that is, yeah, your pay select is high, but your enable is low. Okay, this particular represent the state 0. Go with the coloring of that, so you'll understand it more appropriate. So this is called setup phase. So you are setting up the slave, you are selecting a slave just to make sure that it start setting up itself by knowing that it has been selected for some transfer. Okay, so this is called setup phase. Now as soon as setup phase completes, you need to enable the slave and try to say the slave that you are trying to get something from it. I'll try to take green color. So this is access phase. This comes into picture when you are changing the enable signal, which is this. Okay, you see this. Okay, which is this part. Okay. Now you have P select, which is there. Now you have P enable, that is making sure that your slave is selected and enabled for its working. Now at this point you are saying the slave to start accessing something from that. Okay, your master trying to access it from that. So this happens every state. To get transfer from one state to other, it takes one clock cycle. Okay, now from here to here, you are taking one clock cycle. From here to here, you are taking one clock cycle. Okay. So this is basically happening in 2 clock cycles. When it comes to this part, the slave takes the address, takes the data, either read or write. So if it is read, you are taking the data and you are just doing the transfer what is happening. And then you have, let's say you want to still make some more transfers that need to be happen from the master side, which will be, there will be one more signal which makes sure that either it need to be what you say, to have one more transfer, or it just want to go into the idle phase. I'll try to rub everything. Till now, any doubts? Till how this three is happening? Backwards and all we'll try to see, and P ready zero is also we'll try to see how this is happening, how the weight states are getting added. We'll see in the link. Till here, anything, any doubt? This also we'll try to see. Okay. Anything till here? Okay. No doubts, right?
Yeah,
No,
no.
Okay, fine. So I'll try to rub everything.
Danny,
Nada.
in that last access phase is there, no?
Uh, access
It's
phase, yeah, yeah.
you leave that period is equal to 0.
Uh,
Period is
period.
equal to 0. That
Period,
period,
yeah, yeah, yeah,
that is like wait state only. So it will stay in the same state.
yeah, yeah.
If
That's what
period
I
is equal
was
to
about to say. Yeah.
if period is equal to 1 and the transfer, why is it going back to the setup state once again?
1 second, I will try to say. Okay, now we are saying we'll try to access. Okay. Now this is wait state. So in
Hmm.
order to say how we got it here, which is 0. So 0 is making sure that your P, whatever your period is there, it is not yet. So it is adding wait states and making sure it is in the data phase. Okay. Now the
Fine.
reverse, which is P ready. Okay. P ready one, in this particular phase, you will do the transfer and this particular transfer gets completed. Okay. And there will be one more signal which says there are still more transactions that need to be happened. Let's say after address one, when you are working with a burst of transfers one after the other, so you have something address one plus 8 bytes. Okay, let's say the data that you send is 8 bytes of width. Okay, and your address will be plus 8. Now this will indicate that P ready, don't go back to this cycle, try to go to setup phase and start setting up yourself to do the second transfer. So in this criteria also, you have one cycle that is from here to here and one cycle from here to here. So in this particular case where you are going for you are ready, you're getting ready for the other transfer, you still have 2 cycles. I'll try to have one. So everything that
So
comes,
basically, is it from like access to set up one cycle and set up to access
yeah,
another
yeah.
cycle?
Here to here, it will take one cycle. From here to here, one cycle. So basically, for the second transfer, after completion of first transfer, which is happening here, for the second transfer, this will act as an idle. Similar to this, it will act.
Okay.
So rather than going here, which makes it 3 cycles, from here to here, one cycle, here to here, one cycle, here to here, one cycle, 3 cycles, which are not supposed, which are not required. So if you have one more transfer, this acts as an ideal case. Now you see this as here. From ideal to setup, we are taking one more cycle, like how we are taking from here to here. And from setup to access, you are taking one more cycle, which is very much similar to having a new transaction. Okay. So that is
So,
what it is. And let's say your master is saying that I don't have any transfers left, which is basically your bridge. APB bridge, like the bridge acts as a APB master. Okay. So now you're saying that okay, there are no transfer that are left. and it goes PRID will be 1, but you'll get an indication that there are no left transfers that need to be happened. So it goes to the idle state, and it starts continuing from here for the new transfer, which is very much similar to what we discussed for the first time. This is very much about the how the transactions, how the states are getting transferred, how is a brick, a slave getting ready for and giving transfers to a master. Okay, any doubts in this? So we will be closing this if after this we'll start with AHB. Okay. So any doubts in whole or in particular to state diagram anywhere?
So up to this, if we like APB is enough, right?
Yeah. Even this is not needed for ourselves for doing the project because we are not working on designing AHB or APB. This is just required in order to understand the bridge state diagram. There is a state diagram for the bridge, which have so many states. But when you understand APB, how it is taking 2 cycles to complete a transfer, you will have APB bridge, which is state diagram, APB bridge state diagram, very much similar to this, but a bit complicated. But when you understand this, only when you understand this, you can understand that one. So that's why we are discussing about this. And you don't have to actually implement this because we are not implementing AHB or APB in any case. So we are just implementing the bridge. For implementation of bridge, this is required to understand. That's it. Any other doubts about this? Anyone? Jaswin? Okay. Okay. So we'll wind up this session, and after 1 hour or 1.5 hours, we'll try to meet again. Try to take some time for this night. Will maybe it may go extended for 11 o'clock or 11:30. Try to take the time out for today. Huh?
Okay. I'll drop a message when we have to join the
Yeah,
meeting.
sure. 9:30 or 10 in between. We'll message. After that, we'll start one.
Sure.
Okay. So yeah, that's it. Anything, Sumuka, that you want to add in this till here? Okay. Everything I covered, no? Is there anything that is left?
Yeah.
Okay. So till here, it is all about APB. When we are discussing the state diagram of the bridge, we'll come back to here. But until then, we will not touch APB again. Okay. So yeah, that's it.
That's it.
Yeah.
Then you come for dinner.
Yeah. Anything? That's it, no? Okay. Okay, then I will end the session. Bye.
Bye.